Welcome to qnawire.
Here's the diagram of the system. We know that the angular momentum would be equaling the mass of A times the perpendicular position with respect to A times the linear velocity v. This would be equaling m sub A times r sub A sine of phi multiplied by the angular velocity times r sub A sine of phi. And so the angular momentum would be equaling mass sub A, r sub A, a quantity squared multiplied by the angular velocity times sine squared of phi, of angle phi. We know that the angular momentum vector constant in both magnitude and direction. So we can actually say that it is constant in magnitude and direction. So we can say that the derivative of the angular momentum vector with respect to time t would be equaling the net torque. And because it is constant, this would be equal to 0. And so this would be equaling force sub A times d minus r sub A cosine of phi plus force sub B multiplied by d plus r sub A cosine of phi. And so we can say that force sub B would be equaling the negative force sub A multiplied by d minus r sub A cosine of phi. And this would be divided by d plus r sub A cosine of phi. Now, we know the mass is moving in a circle, so we must have a net centripetal force pulling in on the mass. This mass, F sub c, we can call it, this would be equal to the mass sub A times omega squared times the position with respect to A times sine of phi. And so by Newton's third law, there must be an equal but opposite to the left on the right and the axle due to this mass. And so we can say that the force net on the axle, this would be equaling F sub A minus F sub B minus F sub C, and we can simply substitute. So this would be F sub A minus negative F sub A multiplied by D minus R sub A cosine of phi divided by d plus r sub A cosine of phi. And this would be minus m sub A omega squared r sub A times sine of phi. We know that this is going to be equal to 0, and so we can solve for f sub A and say f sub A is going to be equaling m sub A omega squared r sub A sine of phi multiplied by d plus r sub A cosine of phi, and this would be divided by 2d. And so this would be our answer for the magnitude of force sub A. Now, for force sub B, we simply have to substitute this into this force sub A here. And so we can say that the force sub B is going to be equaling minus m sub A omega squared r sub A. This would be sine of phi, and then this would cancel out with the denominator. So this would be multiplied by d minus r sub A cosine phi, and then this would be divided by, again, 2d. And so this would be our answer for the magnitude of the force sub B. That is the end of the solution. Thank you for watching.